Worked out examples. The first problem. The pinch off voltage for an N-channel JFET is 4 volts. When VGS is 1 volt, then the pinch off occurs at what VDS? That's equal to 3 volts, 5 volts, 4 volts and 1 volt. This is given in gate. This problem is basically to understand the link between VP and VGS and VDS. VDS is equal to VP if VGS is 0. If VGS is 1, we need to substitute there. So VDS is equal to VP minus VGS. VP is given as 4 and VGS is given as 1, therefore it is 3. So the option is 3 volts. That's why I have been telling you that VDS is equal to VP if VGS is 0. So for VGS 0, whatever the characteristics come, that will be equal. In other words, VGS and VP, they are equal. In case they are equal to VGS equal to 0. So VP minus VGS, 4 minus 1 is equal to 3. Option is A. Let's go to problem 2. In N-channel FET, JFET, VGS is held constant. VDS is less than the breakdown voltage as VDS increased. What happens when VDS increased? Conducting across cross-sectional area of the channel S and the channel current density J both increase. As area decreases, J decreases. As area decreases, J increases. As area increases, J decreases. If you see the relation between the current density and the area, generally we know J is equal to I by A because current density. Then what should happen? That is inversely proportional to area. Therefore, as S decreases, current density increases. That's the option that we can comfortably have. This is everywhere true, more so here. So option is C. Third question. The pinch off voltage of a JFET is 5 volts. Its cutoff voltage is. So the pinch off voltage is given, and what is the cutoff voltage? Root 5, half of it equal 5 power 3 by 2. Since pinch off voltage is equal to cutoff, therefore the cutoff voltage is 5. Because if you see the transfer characteristics at pinch off voltage, it's no current. No current means what? Cutoff we call it. So option is C. Option is C. Problem 4. An N-channel FET has IDSS 2 milliampere and VP minus 4. Its transconductance we have to calculate for VGS minus 2. The transconductance formula is GM is equal to 2 into IDSS by modulus S VP 1 minus VGS by VP. This is 2 into 2, 4. This 4 cancel. 1 minus 2 by 4, half. So this is 0.5 milliamperes per volt. So option is B. Option is B. Now we are going for a common data question where W5, problem 5 and 6. The channel resistance of N-channel JFET shown in figure below is 600 ohms when the full channel width is 10 micrometers is available for conduction. The built-in voltage of the gate PN is minus B, 1, where the gate source voltage is 0. The channel is depleted by 1 micrometer on each side due to the built-in potential, and hence the thickness available for the conduction is 8 micrometer. This is all the data given for us, and this is the thickness of the channel P plus and N channel here. Now the question. The channel resistance when VGS is 0. So what is the equation for channel resistance? You see here, built-in potential is minus 1, he said. VGS is 0. W1 is 1 micro. The depletion layer width is root of proportional to VGS plus VBI. VGS is 0. For VGS is minus 3, what is W2? So W1 is VGS1 plus VBI. W2 is VGS another VBI. So built-in potential is same, which is minus 1 here. VGS is 0 here, 3 is here. So W2 is equal to W1 by W2 is half. So therefore W2 is 2 times of W1. And 2 times of W1 is how much? 2 into 1 is 2 micrometers. There is a relation between VGS and VBI linked to the width of the junction depletion layer. So as the channel width increases, channel resistance increases there. For 10 micrometer, channel resistance is 600. Therefore, for 8 micrometer, how much? Then for 600 into 10 by this, 750. So this is about channel resistance we have. Therefore, option is C. Then problem 6. The channel resistance when VGS is minus 3 volts. Minus 3. Now the voltage is changed. How much is the channel resistance? VGS minus 3. Therefore, channel width is 10 into 2. 10 minus 2 into W2. So 10 minus 2 into W2 is 4. 6 micrometers. So for 6 micrometers, what is the ratio? For 10 micro is 600. For 6 is how much? That is 1000 ohms. So that is the option for C. 1000 ohms. Let's go to problem 7. The JFET in the below circuit has IDS is 10 milli, VP is 5. The value of the resistance RS for a drain resistance of IDS 6.4 milliamperes. IDS is the current in the drain. Actually, current we always show one terminal, but only in FETs we show two terminals. Because the same current is flowing in both the drain and source, it is called VDS. So we need to calculate the value of resistance RS by looking at your current equations. So let us substitute our equations. IDS is equal to IDSS into 1 minus VGS by VP whole square. 10 milli 1 minus VGS is VP is 5 and VGS we have to calculate. When you calculate VGS, it becomes 1. So when you got the VGS value, then apply the KVL here. 0 minus VGS minus IDRS. Therefore RS is 1 by 6.4, 156.25 ohms. Therefore option is D, 1.6.25. See here, it is approximately D. Okay. Problem number 8. A JFET is set up as a follower with mu is equal to 200, is very high anyway. RD is 100 kilo and source load resistance is 1 kilo. The output resistance R naught we have to calculate. So how to calculate output resistance of this combination? Generally, output resistance is given by 1 by Gm into parallelly R. What is Gm? 200. Mu is equal to Gm RD, and mu is given, RD is given. Gm 2 milli. R naught is 1 by Gm parallel RL. 1 by Gm is a resistance, then parallel RL. So that is 333 kilo ohms. Therefore option is C. 9th problem. Compare the bipolar transistor and JFET. Compared to the bipolar junction transistor, JFET has larger gain bandwidth product, is less noisy, has less input resistance, has current flow due to only majority carriers. So options are 2 and 4. Because less noisy and then current flow is due to majority. Therefore option is C there. Why? Because if you see these characteristics, FET doesn't have large gain and FET has high input impedance. So 1 and 3 are wrong, only 2 and 4 are right. Therefore C is the option for it. 10th problem. How is an N-channel field effect transistor operated as an amplifier? With forward bias at gate, no. With reverse bias at gate, yes. With open circuit gate junction, with a short circuit gate junction. So with this, you can say option is with reverse bias at gate. So reverse bias at gate has become the best option. That's about JFET.